Okay, so my name's Paul Gardner and I work at Dunedin School in Edinburgh, and tonight I'm talking about SQLite on Repl, particularly for the National 5 and higher database assignment type of work. The techniques required for the 2020 National 5 database task required the pupils to add validation to 2 existing populated and related database tables, as well as write some update, insert, and select commands. And in this task, the starting point for the pupils was to examine a data dictionary document and a supplied database and identify 2 fields where the required validation had yet to be applied. So with a group of pupils from home working, we've been working through all the previous National 5 database assessments using Repl. So for this one, I'll dive straight into Repl. And this is the pupil's view. Make sure I'm using the right one. So I created and populated a SQLite database in Repl and published it so each pupil has a private copy. When the pupil first opens the Repl, they'll see a set of files and folders with some instructions and comments in the main SQL. The file isn't run automatically when the Repl starts, and the pupils can explore this Repl with the main file browser on the left, the console tab, and the shell tab. The console tab offers an interactive SQLite session and starts automatically with an empty in-memory database. So the pupils can dive in here straight away and just a schema command. Because it starts an empty in-memory database, then there is no schema to show, but you can explore databases in this Repl by opening it, if I type it properly. And that's the current populated database that I've supplied. The shell tab offers an interactive Unix shell session, and that can be used, for example, to explore the file system. The run button runs the main SQL script and displays the results in the console tab. And at the moment, all the SQL script does is open the main anytimeflowers.SQLite. So if I try my schema again here. See, this is open the database. But one of the things we were looking at when we were using Repl and SQLite to start off with is how it's not particularly easy for exploring the database. So in the templates that I provide the pupils with, the pupils can uncomment a line that I've prepared, and if they run the script again, then what they get is a SQLite database web browser. And this provides a small web interface to the database. The list databases link searches and finds all the SQLite databases, all the files ending .SQLite in the file list. Clicking on a file gives you a formatted definition of the tables, and clicking on a table gives you data in the table. This is quite a handy feature for exploring the database, but it's a bit constrained in here. So if you click in the top right-hand side, you get a new tab, and you get the same again, but you just get it in a slightly larger screen. And these 2 are independent, so you can keep that going there while you're working on the scripts here. So moving on to the work the pupils needed to do. Let's just scroll down here. So I had slides prepared in case the Repl was misbehaving, but I'll just talk through the work the pupils are supposed to do. The first stage was to add validation to the existing database. Now, one of the limitations of SQLite is it's actually difficult to add validation to a populated database. It doesn't support the alter table add constraint command in the same way that Oracle, MySQL, and MariaDB do. So the approach I've taken here is I've given the pupils a main.sql, which has some guidance notes, and then a series of numbered steps that they can work through. So the first step here is to add the validation that's required. For example, there. And then uncomment this read command, and this command will execute that build tables. And again, if you need a bit more space, using SQLite commands echo on and echo off, you can get formatted output here, but actually, again, the database browser here is quite helpful, and it shows that the validation's been added. And if I click on customer, it shows now this is an empty database table because the script dropped and recreated it. The script also contains a read command that will read this file, which will repopulate the existing data given the CSV files that are provided. So if I run the script again, you can see now I've re-imported the data, and now I've got my populated tables back. The next part was the pupils were expected to write some SQL queries. And again, the structure I've found that works quite well, and I've been using this with pupils for a while now, is that they get to create their queries in here, and they're called from the main script. So if we just take an example query. This was to insert one value, one row of data. I have to remember to uncomment the read command. Something odd there. There we are. So I'll show it in there. I come back to here. So you can see that this little web browser is quite handy for seeing the effect of the SQL. One of the problems that the pupils found quite commonly in using SQLite is the commands like echo on, echo off, changing the mode, whether you've got headers or not, makes it quite difficult to create a useful display in the console that you can then copy and paste to provide the documentation that you require. So two queries are written into there. The next part was to debug a bit of existing SQL. And again, if I go back to here, uncomment this one. Now I can recomment the builds tables, point out those, just so that the console will only now display being executed here. And this is what the pupils are presented with for this part. They're expected to work through this, test this SQL statement. And my pupils have been experimenting with this to work out, well, what's actually going wrong here. There is no customer name, so you can. In here, it's a forename. And a surname. No such column size, because it's not called size. And no data. Now that doesn't mean there isn't. So put an echo on in there just to make sure we can see. So the data is being executed. So the SQL is being executed, but it's really because that's my list of tables. My bunch sizes are all small, medium, and large, so it's not smallest. Small. There we are. So this is the approach I've been taking for doing national 5 databases. For higher databases, I've gone for a much simpler approach, which is to give the pupils a much simpler. Sorry, I'm looking at the wrong screen there. To give the pupils a much. Try that again. No, it's not in here. Yes, for the higher, I'd make a much simpler interface here. I give the pupils a populated database, very little guidance, very few scripts, and they get to explore much more on their own. The advantage of that is they can spend more time working on the console. They get used to much more about interacting with the database. And with the high pupils, we've been working on SQLite databases that interface with Python, and doing it all under this structure. So let's see what we're up to. At the end of their session, once the pupils are happy with their work, they can submit their Repl, and I get notification that the Repl has been completed. But one of the things I've found is that I'm using the Teams side of Repl, and although people can submit a Repl, it doesn't stop them from resubmitting it or changing it. So I've been using the download as a zip file option to get a point-in-time copy of that. Going back to the higher techniques, I create a much simpler Repl project that just has the database and a few scripts. Thank you.